Let's do a new exercise, housing assembly in SolidWorks. Here we will create each and every part of this housing assembly and assemble at the end, and even we will make this simple exploded view and animation for this simple assembly. I hope you like it. So let's start to make this assembly. Okay, this is the assembly of housing. Now you will see we have one full assembly, then there is one section view. This is the top view, and this is section E. This is the section view of this, and you will notice all the parts. There are total 5 number of parts. Then there is a side view. You can observe. We will take this all exercise one by one. Come down and check notes. All dimensions are in millimeter. All fillets are 2 mm. Hole and threads are ISO standard. Now here we have a table for parts: body, flange, piston, ring, screw, M8 into 12, steel alloy. There are number of quantities, everything you can see here. Okay, let's go to our first part. Now this is our first part, body. Now this is the top view, this is the section view. So we will start with this 80 dia, 10 millimeter. Now these length 100 millimeter, and the total diameter 50. And at the end there is a you will see this section view 45, not 45, you will see at bottom 60 square, and this is also going to be 10 millimeter. Okay, even though if you want to add this one, this hole, this diameter 40, we can do it. Let's see. Now let's say right plane, sketch. Now let me select line and start from here. Connect. Now draw one line from origin and make sure this line is construction line. Okay, smart dimension. Now let's define outer diameter. If I'm going to keep my cursor outside, it will show you diameter. If upside, it will show you radius. So keep diameter 80 millimeter. Now this diameter 50 millimeter, and this one internal hole 40 millimeter. Okay, now the thickness 10 millimeter, and this one going to be 100 millimeter. You're right, 100 millimeter. Go to feature and activate revolve boss base feature. Now see, by default system took this center line as an axis of revolution. Keep end condition blind, and here apply angle 360 because we need a complete circular body. Say OK. Select this face, sketch, activate here center rectangle, start from origin point or center point. Now we need to select center rectangle. Right click, choose select and exit. Now hold shift key and select these two lines, and here make constraint equal. Smart dimension. Now this is going to be 60 because this is 60 square. Okay, now select this internal because we need to extrude 10 millimeter. Convert entity. Extruded boss base. Now see, we need to add, keep start condition keep same, end condition make blind because we need to move in any one direction. You will see the arrow direction. Depth 10 millimeter. Make sure merge, otherwise this is become body part number 2. See. Now let's add this pipe from upside 35 50 millimeter from here to here. Now check this upper radius diameter how much. You will observe here 54. Okay, then there are hole, this hole depth 20, then one counter bore hole, depth 4 millimeter but diameter 30. Okay, so 1 2 and the outer one 54, and the thickness you will see 8 millimeter, 50 millimeter from here, And this internal one you will observe here, see, 32 millimeter. So let's choose top plane, plane, and here choose distance 50. You will see. Okay. Now select the plane one, go to sketch, activate sketch, draw circle. Now here I'm going to draw all the circle at a time, so that only I'm going to need, there are total 4 number of circles. Now select the center point, hold shift key and origin point, make constraint horizontal, vertical, and distance from outer edge. $35. Okay. Now the outer diameter 54. Then the counter bore hole diameter 30, and internal wall 32, the extruded wall. Then there is a hole. The hole goes to be 20. Okay. Now here we have to extruded boss base. Now there are too many close profile. So at the end there is a selected contour. Keep end condition blind. Now first I am going to make 8 and select the outer circle. Clear. Don't choose region, otherwise it will select only edge. Now this is moving upside, make it down, say OK. Now let me hide this, click and hide. Now drop down this extruded boss to select this sketch, again apply extruded boss base. Now here start condition same, blind, and here I am going to select, okay, let me choose first edge. Now 32, it's going to be downward side. Okay, reverse and choose here up to surface, select this surface. See, okay. Now again select the sketch 3, extruded cut. Now don't cut through, keep blind. Now here depth 4 millimeter, and I'm going to choose the third circle. This is going to be 30 millimeter and depth 4 millimeter. Say OK. Again same thing, extruded boss base. Here in selected contour choose this, and here I am going to select, let's say next. Next means internal face. Fine. Oh, see, the hole is created. Now the corner hole, there is a hole 9 diameter. See, 7.5 is radius, 45 is distance. Fine. Then the radius all 2 millimeter. Let's first fillet. Keep constant type fillet. Here choose symmetric and radius 7.5. Now I'm going to select one edge and it will show you these options. So select the first one and it will select all 4 corners. Say yes. Hole wizard. Now select the third option, hole. Now here I am going to choose ISO standard because this is the mention in our drawing. Drill size and the diameter goes to be 9 millimeter. Now here choose end condition up to next. We don't need any countersink, so uncheck this. Position. Now we have to choose face. So I'm going to select this face. Now see, now tool is activated. Now just keep cursor over this edge and you will see midpoint, center point. Center point is actually the location. Keep cursor over edge and you will see the preview. Look. Now fillet. Now this time constant type, radius 2 millimeters, symmetric, keep tangent propagation. So the curve created is tangent to both faces. Now if I am going to select this face, I don't need to choose all the edges one by one. Let's say this one. Okay. See. Okay. Let's make there is a hole. This hole you will see, observe here in section view. M8 4 number of holes, 30 radius. Okay. Now from top side there are M6 4 number of holes. This is going to be 42, the pitch diameter. That's it. Hole wizard. Now here choose tapped hole, ISO standard, and here choose tapped hole, not bottoming hole, because we need to make throughout hole. Now here first I am going to choose M6 up to next, thread also up to next, with thread call out. Position, select this face, right click, uncheck. Circle. Let me draw one circle for reference. Now select this point. Now before going to apply dimensions, (42). Now I am going to apply here point. Either you can apply all or one by one. So let's say I am going to apply at one this horizontal position. Say OK. Go to option, documents, detailing, activate shaded cosmetic thread, circular pattern. Now feature, select this one. Now here direction, any circular edge or axis. So I am going to select this circular edge, outer face. Equal spacing 360 degree. Okay. 4 number of instances, means this 4 hole going to divide by 4 and going to place the location. Again hole wizard, same tabbed hole, ISO standard tabbed hole, M6 no, now we need M8. End condition keep next, thread also up to next, thread with call out, position, select this face. Now activate circle. Draw one circle for reference. For construction, smart dimension. Now this is going to be 60. Now activate this point and activate the tool. So let's say I am going to place, okay, any position, that's the, okay, circular pattern. First you need edge or axis. So let's say center one, 360 degree, equal spacing, 4 number of holes. So 360 divided by 4, and this is the, it is going to place at 90 degree at every steps. Now the tapped hole is created. Say OK. See. Now this is your part number 1. Even if you want to apply edit material, now alloy steel 7700 kg per cubic meter, apply, close. But I need some different appearance. Click here, edit appearance. (190). (186). This is the color we need. Okay. Now let me save this one. Save any drawing. This is your first part. So I'm going to write only body. Save. Okay. Let me select new part and voice part. Okay. Now let's make the next part is flange. Okay, the outer diameter 80. Now this one depth, this diameter 38, 20 is the width, and this flange depth 10 millimeter. Okay, then there is a hole 25 diameter, 16 depth, and there is M16 hole. Uh, let's try to make this one what we say real thread. So here we will make the hole M for M16 we will make hole M14. Okay. Now right plane. Okay, let's go for right plane. Activate line tool. Make the center line construction line. Now first define diameter 80, enter. Now this one 38, 10, and this depth, total depth 30. Revolve boss base. Due to this construction line profile is open, so system asks, you will see this notification, say yes. By default, system took this center line as an axis of revolution. Keep end condition blind 360 degree. Now here we need to make, okay, let's use hole wizard, counter bore hole, legacy hole. Simply choose here counter board. Now first hole, outer hole is bigger, that is an inner hole is going to make 14. So for thread depth, what you choose up to next row, so it's we will not be able to change. Now counter bore diameter 25, depth 16. Choose position, select this face and place here. You will see the preview. Okay, that's it. Now here M16 hole, a thread. So I'm going to drop down here, choose thread. Okay. Now here I'm going to select, okay, let's start with here. Okay. Now come here up to selection. Select this internal face. Okay. Now here we need to cut hole. So here I am going to choose tab. See diameter M14, 2 is pitch, M16. Okay, M16 into 2 millimeter is going to be pitch. Cut thread. Okay, one more right hand thread. One more thing. Let's apply some offset because the end will not be perfect. You will see here end is not going to be perfect. So I am going to apply offset 1 millimeter reverse. We need more than 1. 2 millimeter. See thread going to outside, and for inside also we need offset 2 millimeter. Let's check this is coming out or going inside. Okay, that's fine. Say okay. Section view. Okay. Now you will see the thread. This is the real thread. Okay. Now at corners there is chamfer 3 into 45 degree. Okay, and there is a hole 90. This is counter bore hole 596 counter bore diameter. and there are 4 number of holes. Okay. Now pitch 60. 9, 15, 6. Okay. Now chamfer. Keep angle distance tangent. Now here select 3 into 45 degree and let me choose this edge. Fine. Now select this face. Counter bore hole. Again choose legacy hole, simple counter bore. Now the hole diameter 9. Depth we selected up to next, so no need to apply depth. Counter bore diameter 15 and depth is 6. Select position, select this face, and we need to apply somewhere here. Right click, choose select smart, draw a circle. For construction, smart dimension and make diameter 60. Okay, now activate this point, activates hole, place here, exit. Okay, circular pattern. Now first we need to choose any axis, so I am going to select this circular face. Is equal spacing 360 degree. We need to divide these 4 number of patterns with 360 so that we will get the location for this hole, and hole here selected. Geometry pattern, edit material, alloy steel, apply, close. Now go here and apply color. I want to change this color, that's why I am going to apply something like this. $188. Okay. Now let me save this one. Flange. Let's go for third part. So new part. Okay. Now let's make this part. This is piston. Okay, first we will make this body, outer body. Okay, this is M16 thread. So this one is going to be, okay, 70 from here to here, 20 plus 70, total 100. Okay, so this is going to be 10 millimeter. Fine. Now here angle 45 degree, this is going to be 16 and this is going to be 12. And there is a chamfer, 3 number of chamfer, 145. Let's see how we can do this. Now which plane is suitable? Let's go with right plane, sketch, activate line tool and start from here. Go back and take little angle and connect, exit. Okay, bottom one keep construction, smart dimension. Now total length going to be 100, 10. Okay, now select this one and select this point and you will see this stride. So select this one, again apply this point, thread 45 degree. Okay, now let's apply distance from here to here, 70. Let's apply diameter, 12. For this 16, because we need to remove material for thread. And this one 38. Feature, activate revolve boss base. Due to this construction line, the profile is open. You will see this pop-up, say yes. By default, system took this center line or construction line as the axis of revolution, and we need complete body. So in blind, you choose angle 360 degree. Now there are chamfer, angle distance 1 into 45, 1, and select this face. Okay. Now here we have chamfer. Now let's cut this thread M1640, this thread only up to 65 millimeter, and there is a hole 6 dia 4 5 6 millimeter from here. Then we need to make this cutout. This cutout you will see 3.5 from this end and 3 millimeter total, and you will observe here the distance 0.2, this is the 0.5 angle and something like this, 0.4 and 34. Let's do this. First let me make hole. Top plane, sketch, circle, and let me draw one hole. Hole diameter 5 and distance from here 6. Is still not defined. It means we have to apply some constraint. So select the center point, hold shift key and origin point and make vertical constraint. Now here choose extruded cut. Now here I am going to choose in direction 1, choose through all both. See? Okay. Now activate here thread. Okay. Now location, I am going to start from here. Offset, keep 5 millimeter. Up to selection. Now here I am going to choose up to, make hole here. You will see the preview. Now this is going to create a tab. So I want to make a die. So make metric die. In die we need to cut. M16 into 2 is 16 2 millimeter pitch. Cut thread. We need to remove material. That's why we choose cut thread. Right hand thread, because in previous we use right hand. You will see 5 millimeter. Distance 5 millimeter from here to here. Say OK. Now for proper aesthetic you can create something like convert entity, extruded cut. Only one side. Okay. Uncheck other side. Okay, even 10 is enough. Even you can choose through all is better option. Okay, it gives you little aesthetic look. That's the thing. Okay, now here we need to make some hole. So right plane, sketch. Okay. Now activate line tool. Okay. Draw one center line. Find out midpoint to connect midpoint to midpoint. Fine. Select construction line, again make constraint vertical. Now this is symmetric image. I want to do some more. Okay, smart dimension. Now this distance from here to here, .5, 3 millimeter. Okay. Now the angle between these two is 5 millimeter. Okay. Now I am going to apply one center line. Draw one horizontal center line. Smart dimension, Distance from here to here, show diameter 34. Let's check. This is fully defined sketch, okay? But, okay, radius we will make later. Extruded cut, revolve cut. Now here we have to choose axis of revolution. So select this one. You will see profile is selected. We need apply 360-degree. Now here apply fillet, constant type fillet. Now come here 0.2 multi-radius. See what will happen multi-radius. These two outside are 0.2, but if I'm going to choose inside one, this is going to be changed. This one make it 0.4, little bigger, and these two corners are 0.2. Okay, now see, we achieved our result. Edit material, alloy steel, apply, close. Appearance, I am going to double click, edit appearance. (190), 188, 186. Close. Now let me save this one, piston. Go to drawing. New part. Now here let's make a ring, and ring is, you will see, 2.5 diameter, 34 internal, 39 something external. So let's see. Right plane sketch. Draw one center line, horizontal and vertical. Draw one circle at this point. Smart dimension. Diameter define 2.5 millimeter. Okay. Now, hold shift key, select bottom to here, circle, and keep diameter. This is inside diameter. And how much? 33. 34. You will see the preview. This is fully defined sketch. Revolve boss base. Now here you have to apply axis of revolution. So I'm going to apply this line. You will see the preview. Say OK. Rubber, you can apply, edit material, drop down, and rubber available, non-metal rubber. Apply, close. See? This is piston ring. Now last is screw M8 into 12. You will see depth of head 5, 13. 13 is the outer diameter. This is M8. For M8 we will make M8 1 into 45. Now there is a slot 1.75, depth 3.5. And this is cosmetic thread. Fine. Right plane sketch, activate sketch line, draw a shape of screw, construction line. Now apply dimensions. (12 plus 5 17) 5. Now let's apply diameter 13. Similarly for this 8. What dimensions? Okay, this is going to be 12. Revolve boss base. Due to this construction line, the profile is open. You will see this pop-up, say yes. By default, system took this axis center or construction line as an axis of revolution, and here you have to apply angle 360 degree. Say okay. Now I am going to apply slot here. Now make tangent relation between this curve and this line. Smart dimension 1.75. Go to feature and select extruded cut feature and make depth 3.75. Okay, 3.5. Okay, let's okay, chamfer we will make later. Let's make chamfer. (1 into 45). Choose here angle distance, tangent propagation full preview, and select face or edge. Now I want to apply cosmetic thread here. Go to insert. Now here annotations, cosmetic thread. Select edge. So I am going to select this edge. ISO standard machine thread M8. Okay. Up to next. Say okay. If you don't see thread, just apply documents, detailing, shaded cosmetic thread. See. Even you can take from system. Okay, let's change the color for this. Let me save this one as a screw. M8 into 12. Okay, let's make assembly. Here choose new, assembly, open. Now before going, all the parts already here because these parts open in background. View origin. Now select this part and keep cursor over origin point and see this is going to coincide. Click and see the part is applied. Now let's change, hide everything. Now we don't need this. By default, right click, float, means this part is fixed. By default, first part always fixed. I'm going to make sharper edge. Now let's add flange. Now this part should be inside, so here we have X, Y, Z. We have to rotate, so we will rotate along Y. So click here Y, 1, 2, 2 times. Click somewhere here, mat. Select this one and this internal face. Concentric relation. Now look, this is moving along with this. Select this face and this face. Now this is going to create here coincident relation. Fine. Now still, let's check. Okay, still this is rotating, so we have to apply, select this hole and this hole. Now this is going to coincide. Okay, not coincide, this is concentric actually. Now this is fixed, it is not going to move. Okay, here choose component, piston. Okay, this is the exact position we need, so place somewhere here. Okay, mat. I am going to apply, let's say, activate here temporary axis. This is important. Mechanical mat, screw. Now here select this axis and this axis. Now revolution per mm, distance per revolution. We have pitch 2 mm for this, so I am going to apply 2 mm. Say OK. Let's hide this temporary axis. Look, this is going inside. Insert ring. Okay, place here. Now click on this, hide. Okay, how do I fix this one? Drag this one. Let's check first temporary axis, mat. Now select this temporary axis as this. Here choose tangent relation, a coincident relation. Okay. Now fine. Now we have to fix with at center. So let me hide this temporary axis and drop down and open ring. Ring front plane. Okay, this is ring front plane and fine. Piston. Okay, from this face. Now apply here distance, select here distance. How much distance we took? 3.5 plus 3, it's going to be 5. Okay, say OK, cancel. Now see, this is going to apply exactly at center. Now you will see this is going to rotate. Even we can apply some limit also, but that's fine. Let me close this. Okay, not insert mat. For a time being, we need to close this. Now show. Let's insert some more component. What balance? Piston ring screw. Okay, this is at perfect location. Apply here mat. Now I am going to select this hole and this one. First relation coincident, concentric. Okay. Now there is an internal face and this face coincident. Okay. Cancel it. Now there is one more option called copy with mat. Let me select this component, choose here next. Now we have to apply two mats. The first mat is hole. So I'm going to select this hole. Now second option is this face. Select this face. This face. See, both are applied here. Say OK. See. Come again, select this hole and select this face. See, both apply. OK. This hole, this face. OK and cancel. See, the holes are placed. Bolts, screws are placed. Now let me save this one. Housing assembly. Okay, let's make some exploded view. Click exploded view. First, here choose add a step. There are two types of step. One is radial and one is a linear, regular step, or translate or rotate something. Now first I'm going to click this all four screws. See Z axis, remove here. Now here at done, click done. Next, select this one, drag here, say done. Okay. Now let me select this one, body, take little back. Done. Select this one, take little here. Done. Now look, it seems perfect. Say OK. Now right click, collapse. Right click, animate explode. You will see the animations. Collapse. Choose here collapse. Now save this one. Drop down, go to toolbar and here activate motion manager. Go to motion study. Now first, okay, this is basic animation, so we don't need to apply anything else. Here choose animation wizard, explode and collapse. 4 seconds, start time 0, finish. Again, animation wizard, collapse, next. Duration 4, start time 4, finish. Calculate. Now you will see. Now this is going to collapse. Don't forget to share, like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.